Ever wonder how spacecraft glide through the cosmos with such precision? It's not just about big rockets, it's about tiny, super-efficient engines called Hall thrusters. These little powerhouses use electric fields to zap ions and create thrust, but here's the catch. Predicting how they'll perform in space is like trying to forecast the weather with a broken thermometer. So why is this a problem? Hall thrusters rely on delicate physics, like how electrons bounce around in a magnetic field or how pressure changes affect their push. But models, which are basically computer simulations, don't always get it right. In this study, researchers found their model missed some key details, like a 7-degree peak in electron behavior or how pressure tweaks the thrust. It's like baking a cake but forgetting to add the sugar. Everything looks good on paper, but the taste is off. Here's where things get interesting. The team used a technique called Bayesian inference to fix these gaps. Think of it as a smart learning process. Imagine you're guessing how a car handles on a highway. You start with a hunch, your prior estimate, test it on real roads, and then adjust your guess based on what you learn, your posterior estimate. That's exactly what they did here. By feeding their model real-world data, they tweaked its predictions to be way more accurate. Let's talk numbers. Their model nailed the discharge current, the electrical current that powers the thruster, within 5% of real experiments. That's like hitting a bullseye. But when it came to thrust, the actual push, the model was off by 10%. Why? The thruster in space used a slightly higher voltage, 310 V, than the lab tests, 300 V. The model hadn't seen that difference, so it couldn't predict how voltage changes affect performance. It's like testing a car only at 60 mph, and then wondering why it struggles at 80. Now here's the tricky part, anomalous electron transport. Electrons in the thruster don't behave like textbook particles. They anomalously bounce around, messing with performance. The researchers calibrated their model to account for this, but some parameters, like how strong these collisions are, still had a lot of uncertainty. One value, alpha nm, varied by a factor of 2 between models. It's like trying to measure a room with a tape measure that stretches. Your results are all over the place. So how did they solve this? The team built a multi-component model. Think of it as a puzzle with 3 key pieces: a cathode model, a discharge model, and a plume model. Together, they simulate how Hall thrusters behave under different pressures, like the H9 shielded and SBT 100 unshielded. But here's the cool part. They used Bayesian inference to not just make predictions, but quantify the uncertainty in those predictions. It's like giving the model a confidence score for every result. Here's how it works. The model takes inputs like pressure, voltage, and gas flow, then predicts things like thrust and ion velocity. Instead of spitting out one answer, it generates a range of possibilities, showing how confident it is. The team tested this against real experiments and found their model was accurate within 10%, a huge improvement over previous efforts, which had errors over 30%. They also showed the model could predict performance across different labs, which is a big deal for space agencies wanting to standardize testing. One of the biggest wins. The model captured how thrusters change with pressure, like how the ion acceleration region shifts, affecting thrust. Even when tested on unseen data, it still nailed the trends. Plus, they tweaked assumptions about electron movement and plume spread, making the model more flexible for future upgrades. Why does this matter? Reliable predictions mean better spacecraft design, reduced testing costs, and deeper space exploration. This isn't just theoretical, it's about making space travel more efficient. So next time you think about rockets or satellites, remember, behind the scenes, scientists are turning uncertainty into possibility. And who knows? Maybe this kind of research will one day power the engines of your favorite sci-fi dream. Thanks for watching. Hit subscribe for more deep dives into the science shaping our future.